First of all, let me introduce you myself. My name is Tugberk Ugurlu. I am a software developer at Redgate, and I'm also a Microsoft MVP on ASP.NET. And I think they now call it Visual Studio and Development, blah, blah, blah. I'm not sure. So it's not ASP.NET anymore. Anyway, so a bit about myself. I have a blog. I am blogging frequently, so you can check that out if you want. I am also available on Twitter, so I tweet cat pictures and about Formula 1. So if you are interested in that, I am there. I am also on GitHub. I'm trying to be active for the open source stuff. I'm also on Stack Overflow, try to answer some questions and also ask some. As I told you, I work at Redgate, as you can understand from my t-shirt. I am actually originally from Turkey, so I moved from Turkey to UK a year ago. So I have started working at Redgate. It's an awesome company. I recommend you to check that out, definitely. Okay, so today I'm going to be talking about profiling .NET Server applications. So let me get a pulse of the room first. How many of you guys have a server application, any type of server application in production today? Awesome, nearly everybody. So you wouldn't be here if that wasn't the case. So it's kind of a wrong question, I guess. So today I'm going to be talking about profiling .NET Server applications, as I told you. And then the agenda is to go over the nature of the server applications, just to refresh our memories, what are the main characteristics. And then we will talk about profiling the application logs and then the server. And then performance profiling, we will look at how we can pin down the performance problems, and I will show you a few demos. And then there are also other nasty problems like memory problems, which are harder to tackle sometimes. But there are several ways that you can take to make those a little bit less painful. We will also look at how load tests might help you to pin down the problems before you actually have them. So that will be our agenda today. So let me first explain what I am actually referring to by telling you a server application. So you might think that server application is a web application. So that's mainly the case. Your application, which is exposed through HTTP, is what most people call server applications. But actually, they are not the only server applications out there. So server application for .NET ecosystem could be a web application which runs under IaaS. It could be a Windows service. So in that Windows service, so you would have a self-hosted web application and then a worker process maybe to do some asynchronous processing behind the scenes. So these type of applications are what you can put on a server. Before going further, actually, I also have a couple of books here. Some of them are about performance testing and some of them are about memory management. So I would love for you guys to ask questions along the way, make it interactive. So if you ask, good questions, I can give away the books to you. So those type of applications are the server applications, but what are the main characteristics of those applications? So one of them, which is the most important one to me, is that they are stateless. They don't have a state. They don't actually know what you have been doing. Like inside your browser, you can go back and forward, right? If you want to, you can click those buttons. But in a server application, there is a bit of resolution issue here, but hopefully you can see that. So for the server applications, they are stateless. They don't know the state. So you have a request, you are sending a request, and then it processes your request, and then it goes back to you, and then it gives you the response. And it is same for the worker processes as well. It gets a job, and then processes that job, and then moves away, and then processes another job if there is any other available jobs there. So these are the stuff that you do in a server application, so you don't actually have a state there. So one of the most important characteristics is this: they are stateless. So the other one is that you can run them in multiple instances. So you can have a web application. It is one web application that your user sees, but that doesn't need to be in one server. So you can put it on a web farm, and you can host it in like 10 or 20 servers or whatever. Or you can even host them in different data centers, and then you can even do traffic management so that if people are coming from Australia, they would hit a data center in Australia. So you can run them in multiple instances. So what we can get out from this is that whenever you have a problem, it may be your application that is the problem, or it may not be, it may be the server that the application is running on. So as you don't only have one server, it is also get interesting at that point to pin down the problems there. So this is another concern here that we have. And then the other one is that server applications are concurrent. So whether they are worker processes, whether they are web applications, whether they are just HTTP, raw HTTP APIs that you use. So they are concurrent. Multiple users hit your endpoints at the same time, and then the load may change depending on your situation. For example, if you are a retail company in USA, during the Black Friday, you would probably get a very high load. But at other days, you may not get that. So it is changing a lot. So you need to adjust your system based on that probably, or you may not need that. I mean, it highly depends on what you do, highly depends on what is your load is. But the main thing here is that they are concurrent. So your applications are concurrent. You need to design them in a way that it would be okay in a concurrent environment. They are also spreaded and connected. I was actually concerned about this word because I just made it up, but it sounded cool. They are spreaded and connected. What I mean by that is that, so for example, in a modern world, you don't only have one server application which does everything. You probably have a server application, and then you probably have a worker processes, and then you probably have multiple other server applications which does other stuff. So for example, with this new type of deployment technologies like Docker, you can have multiple instances. You can hit different data storage systems in a different web applications or different server applications. So these are spreaded, but at the same time, they are connected. So whenever you receive a request, you do some processing. It doesn't matter you got back to the user at the same time. It still goes on maybe behind the scenes. So that's also one other thing that we need to care about here. And then the other one is, which is not that common, but it is also, you can also see this. There can be multiple versions of one application or a worker processes at the same time. So what I mean by this is that, for example, think about Twitter. Twitter has a public API, right? So probably thousands of users consume that API and build some other applications on top of it. So today, Twitter exposed that API to you, but they cannot change it in a way that it will break your application today. So if they break the API signatures today, your applications will be broken. So what they do is they probably maintain two versions of the same application at the same time, so that you can have a time to actually go to the new version. And then, so what this gives us is that whenever you have a problem, you may have it in one version, but not have the other one. So it may be a case that you may have the problem in one version, in one server, but you may not have that in the same version, but in another server. So these are the, things start to get interesting whenever you have these type of concerns. So it will get harder and harder for you to pin down the problems. So here's my attempt. I did it last night while I was, trying to sleep, but couldn't. So this is my poor architecture. So it's a bit, not being seen by the resolution thing. But what I'm trying to explain here is that at the top, you have 4 instances of your HTTP API. And then one of them is version 2, and then the other 3 are version 1 APIs. So I didn't scale the version 2 that much because I know that not so many people are hitting it. So this is the case here. And that it doesn't actually go and hit the databases always. There are some cases that they hit the message queue system, which is a contract between my worker process and then the applications. So here what I understand is that there are some asynchronous processing going on. For example, take the Amazon case. Whenever you order something, they tell you that your order has been placed. But it doesn't mean that your credit card has been charged, your order was successful, or whatever. They just tell you that your order has been placed, which means that, I don't know what Amazon architecture is, probably it's more complicated than that, but they are probably placing something in a message queue system for a worker process to come and pick it up and then process it later. And then the worker process will process that and then do the necessary things for that thing to be done. And then it will probably store a state somewhere, probably a persistent data storage system like SQL Server, MongoDB, or whatever. And then it would mark that job as processed. So these are type of stuff that you have. And then it starts from you making up the shopping cart and then placing the order, and it goes to a worker process does some stuff, and then it places it on the database and it persists there. So it is a complete loop that you have there, which is not only one thing that you send a request and get a response. So this is more complicated architecture that you have. And then in this case, trying to pin down what the problem is can be harder than just trying to pin down a problem in a console application or a desktop application. So these are the cases that concerns us whenever there is a problem and we are trying to understand what that problem is. Any questions so far? Okay, cool. So yeah, and sometimes when you try to solve these problems, you need all the connected process, all the data, all the connected data to identify what the problem is. So this is what I was explaining before. So, and here enters logging. So how many of you guys log some stuff on your server application? Okay. How many of you guys actually have your server, web server log stored somewhere and look at it frequently? Okay, not much. Cool. It's still cool. You don't need to look at it unless it's a problem, right? So logging is one of the critical things that you need to do if you have a server application, because you cannot go inside it and then look at it. I mean, we all know that we can do that. We can remote desktop into it, but it is not that cool to do that. I'm looking at the logs in a shiny dashboard is way better than just RDPing into your machine. So having reach logging will enable you to trace what the user have done. So remember what we have been talking about before. A server application is stateless, so you cannot actually understand what user has done. Without logging, you may not know that at all. So logging is pretty important. Reach logging is always important, but you need to adjust that based on the system requirements. So you shouldn't be logging like crazy because it may slow down your performance as well. So you need to adjust that level, and then you need to log necessary informations for the necessary things. It doesn't mean that you should only log errors and then warnings. You should also log some information data so that you can trace it back. And then these are the application logs that we have been talking about. But besides the application logs, there are other logs like server logs. For example, if you are under IaaS, IaaS has its own log, right? Whenever a request hits a process, IaaS process, it logs some stuff, and then it hits your application. Inside your application, you also log some stuff as well. So, but at the end of the day, it is the same request, right? So you need to somehow combine them, somehow collect them together and combine them and then look at them together. Maybe you will understand some of the problems by this, looking at the server logs, which may be also important. So we shouldn't ignore them. So there are several ways, several levels, I think, for the logging. One of them is the storing the logs. So this is the first part. So without storing them, you can't do anything because you don't have the logs, right? So one of the tools that I can recommend based on my personal experience is the Elasticsearch. So you can store your logs in a system like Elasticsearch, which you can then go and query and do some aggregation queries on it, which is always useful if you want to do some stuff like if you want to pin down a problem and if you just want to look at the errors and then error logs and then warning logs, or do some rich queries and then maybe have your own dashboard based on the logs. So having a system where you can actually run some queries is really useful. So Elasticsearch can give you that benefit, but there are other tools like Graylog. I think it does some queries there as well. And then the other thing is the centralized logging. So centralized logging is, it has been out there for a while, I guess. But it is kind of a hot topic with Logstash now because it is now so easy for you to centralize your logging. So what this means is that whenever you have an application, and then whenever you have worker processes, and then you have server logs, and then you have your application logs, you can all store them in the same place and then query them together if you want to, or query them separately if you want to. So Logstash gets into way in every system and then plugs itself in and then takes your logs, whatever format they are in, parses them, and then puts it inside the Elasticsearch. This is all it does. So it gives you that benefit of getting it in the way, and then without caring about what format you are actually logging, you can do the middle thing inside the Logstash and then log some stuff to Elasticsearch with that way. And then the last part of the puzzle, I think, is the analyzing the logs. So Kibana is another thing. It is the ELK stack in Elasticsearch, Elastic World. And the Kibana is the last puzzle that you use that to analyze some logs. You can have it has a default way of presenting you some stuff, but you can always have your own queries, always have your aggregated data there. Which is always nice. And then the last thing, I think, which is very important is the log correlation. How many of you guys do log correlation today in any means? Okay, cool, interesting. So we have a nice topic here to talk about that. So log correlation is that whenever you, so for example, assume that you are consuming my API, HTTP API, and now while you are consuming it, you are having a problem. So what are you going to do then? So you should come back to me somehow and tell me the problem. So you should tell me that, okay, I'm having a problem. But how are you going to know that which request was the problem? So you may look at the logs and then they filter them down like error logs or whatever. But you cannot always know that if that is for that user or other user. So the log correlation is a way for you to give something to the consumer so that they can use that unique thing to come back to you and say that this is my request ID and I'm having a problem today. So you can then take that request ID, put it inside your log storage system, and then query the logs on that thing, and then you will have all the trace data for that request only. So this is the log correlation. But there are some tricky things to care about here. For example, one of them is that remember that your server is a concurrent environment. So you may not always be able to do this. In a .NET world, you also have asynchronous processing, asynchronous I/O inside your server. So whenever you do that, you will lose the current state. So you cannot always rely on the current state to put some log data. So you need to do this in a nice way. So here, I have some logs inside Elasticsearch. Look at this data here. It says request ID. So this is being logged in every request. And whenever you start a request on the server, on my server here, underlying infrastructure sets this for me and then logs this for any log that's being written inside your request. So it may not be only your logs. It may be any component that you use and they are logging some stuff and you hook your logging infrastructure to that thing and it will also put that request ID there. So you can have a rich way of identifying what happened in a request. So whenever you come to me and say that, okay, I'm having a problem right now, let's say that you will have the problem here. Okay, I'm lost now. Where am I? Okay, I'm here. Hopefully this will go away. Okay. So whenever I have a problem, for example, here, in this case, so let's assume that this was a problematic request. So whenever I look at it, here, I should see, I'm not putting it there, I guess, right? Okay, here it is. So you can see that inside the header, I'm sending back a request ID. So you can take that request ID and come back to me, and I would be able to run a query something like this, which would just filter out the request queries for that request. So which is always nice, which is always cool for you to have this type of correlation. This is called correlation. So this is a basic one though. So remember that you also have worker processes sometimes. So whenever you have that, you may want to correlate it in that manner as well. So this is just for the web request, but you also have some worker processes. So you may want to do some different things to tie them together so that you can always see one thing being happened and then you can always trace them back. So this is always nice. This is always good to have and one of the things that you should always have so that you can pin down the problems. Otherwise, it will be really, really hard for you to actually identify them. So I gave you the demo. Hopefully it was useful. So the other thing is after the logging is essential. So you need to have the logging there so that you can identify simple, easily understandable problems by looking at the request. But there are some times that you cannot actually understand the problem by looking at the logs. By the way, do you have any questions on the logging stuff? No one wants a book? Okay. I'm going to all take them back to home.
What's the tool that you were using there? I was looking at the URL.
Okay. Cool. Nice question. So it is actually called Sense. So this comes with Marvel, part of Elasticsearch. So you install the Marvel plugin, and then you get the Sense inside that. And it's quite nice. You also get IntelliSense and then code completion for your fields and all that stuff. Which book do you want? Performance testing? Performance testing under the hood of .NET memory management.
Performance testing would be nice.
Yeah. Cool. Do you want to grab it?
Thank you.
No worries. Okay. So yeah, as said, you may not always understand the problem by looking at the logs. So one of those situations is the performance problem. So you may see that your requests are taking long and long but you cannot understand it, what's going on, why it is happening. By looking at the logs, everything seems really fine, but you are having performance problems. So these type of problems are a bit harder to identify. So first thing to do here is to actually go and identify the problem. So after you identify what is going wrong, you may find the solution easier. So don't go and try to find the solution first. Try to identify the problem, spend time. This is going to be the most of the time that you are going to spend to solve that problem. Identifying it like 99% of the time that you are going to spend there. And then pinning down the problem the same. So there's a really nice tool to do this job for you. It's called Ants Performance Profiler. It's a tool from Redgate, which is an incredible tool for you to use when you have performance problems. So you can actually see it in action there. If resolution allows me to show it nicely, but I don't think it will. So you can, in Ants Performance Profiler, what you can do is you can hook into any .NET executable. It would be IIS process, it would be a console application, it would be your service application, whatever. And you can just profile it live or profile it while you are debugging. And when you do that, Ants Performance Profiler collects some data. And one of those data is actually your code. It will pin down what you have inside your code. And if you have, for example, database queries, it will also identify them for you. It will tell you that you have a database query which is slowing down your performance. And then it will also give you a suggestion how you can fix it with a TSQL code sample. So for example, if you are missing an index, it will tell you that, okay, go and create this index, and it will make it better. And when you do that, it will actually make it better. You can profile it again and see that. So there are these type of little things that it does. Also, what it also does is it gives you the HTTP request as well. So it knows whenever there is an HTTP request coming into your application, it identifies them and it pins it down so that you can only see what's going on inside that HTTP request, which is very cool. And as I said, it also gives you the SQL queries which you are running. And then it also gives you what is being shown, what's being run underneath it. So you can actually see the actual query which is being run on your SQL server. And it gives you the time, it gives you how many times you have run it, and it identifies the hotspots there, which is very cool. So I will give you a demo here, which is actually one of my personal experiences, which I had recently. But I didn't use this tool to pin down the problem. I just tried to figure it out manually by myself, which was very painful. I faked the problem here, which is not the real problem that I had, but it is very similar to what I went through. So here I have a really simple, okay, you can see that because it didn't extend. I have a really simple ASP.NET web application here. ASP.NET 5 web application. So what it does is it's really simple, but there is a component that I'm using here which takes a long time to construct it. It does some stuff while it is constructing it, and then but I know that it's gonna consume some time to do that. So what I did was I'm only creating it once per my application. So it is thread safe, singleton. I am using it in every request, so which is cool. But I am seeing some performance problems. So what I did was I came here. Okay, this is going to be very fun. Let me do it that way. Okay. So I came to Performance Profiler. I wanted to run a new session. Okay. It died on me. It doesn't do that usually. It only does it whenever I'm presenting. Murphy rule. Okay. So I have the Performance Profiler here. And by the way, how many of you guys familiar with ASP.NET 5 today? Okay, cool. So briefly, there is another session today, I think, about ASP.NET 5. I highly recommend you to check that out because it's the next big thing which is happening in .NET ecosystem, I think. So it's a complete rewrite of the system. It is still in beta, but Ant Performance Profiler supports ASP.NET 5 applications already. And the guys are doing a really great job on keeping it up to date. For example, this is now working with beta 7, but there's going to be a version which will work with beta 8 now. As ASP.NET team ships new stuff, the team also catches up. So here what I have is my web application. I will choose my runtime, which is beta 7. And then I will come here and hit start profiling. And then it will start the profiling for my application. Now what will happen is, you can see that here it already started my DNX instance, which is the actual thing that boots up your application. And it sends a request. Here, whenever it sends a request here, it will print out a proverb, British proverb to you, which I'm trying to learn nowadays so that my friends don't make fun of me. So here it's better late than never. I don't know what it means, but better late than never. So, and if I refresh, I will see something else, but it is taking a bit time to do that. I'm not sure why it is doing it, but it's still profiling. But it also, what it also does is it also sends a request to behind the scenes through JavaScript to visit its endpoint. It does all the stuff, so it sends some requests there. And as I was profiling, I will stop the profiling now. I will kill it, and it will give me the results now. You will see that here. So it's processing the results. It's trying to calculate what has happened. And then it gives me a bunch of things here that I can now go and analyze. So when I look at it there, I should see some interesting things. So here, you can see that this constructor is taking a bit time to process. I know that this is the constructor that I was telling you about. It takes some time to process, so I know that it takes some time. So it is not a big surprise to me, but I'm creating it once per the application. So I'm still looking at it, why it is happening. So this is the actual bit that slows it down, the initialize, which runs only once inside the constructor. And then I go here, and I'll look at some other stuff, and I see this one. This is the hit count. It says that it is being constructed 7 times. It's being run 7 times, so it shouldn't happen. So whenever I see this, okay, I'm saying that, okay, there is something going on here. So I only know that I'm constructing this object through my IOC container. So I can just go and look at it. So here, I have my application here, and inside the startup class, I am registering it there, and immediately I see the problem. I am registering it per a scope base, which means that whenever a new request hits, give me a new instance, and whenever that request ends, dispose this thing. So this is the problem. It should have been actually at singleton. There is one more interesting thing here. Have you guys seen Visual Studio Code before? Cool, okay. So this is actually giving you full code completion. It's a nice tool to have, and it works because of the new nice things happening in .NET ecosystem. So whenever I do this, I will immediately eliminate the problem. And whenever I profile again, I will see that it is only being constructed once. So what I can get out of from this is that Profiler helps me a lot to see things, get me the insight, what's happening. And as I told you, I can also look at the database calls, and I can see that what I am running. And I can also go and look at the HTTP calls. If I can see request, outgoing HTTP request, not that one. Request from client, yep. So you can see here that I have 7 requests which is being hit here and 2 requests there, and I can actually dive into the code if I want to. And here is the start of the request, which you can see. So it is giving you all these benefits that you can use. This tool is nice for you to pin down the performance problems, but it is also nice for you to explore some stuff. For example, a few days ago at work, I was working in an application which I don't know anything about, and sadly it was a legacy code base, so it was hard to read what was happening, but it is a fully working, fully functioning application. But to understand it, I needed to learn some stuff, I needed to understand it. So I just ran Performance Profiler on it, and I was able to see what was happening, what was going on there. So it is a really nice tool for you to actually discover the new applications that you are working with, which is very cool. Okay. The other thing is, which is a bit more painful, is the memory profiling. So performance profiling can be easier than memory profiling, because memory profiling is a bit harder thing to do, because you don't always know what is the problem, and identifying it is always something which is hard to do. You cannot actually understand it while you are debugging it. You need to actually dig very deep into it. You need to understand what's happening inside your memory. And then one of the things to do that is to take in memory snapshots to analyze your memory in a particular time. To do that, you need to use a tool somehow. So one of them is another tool from Redgate is the ANS Performance Profiler, which is an awesome tool to use. Have you guys ever used a WinDebugger? Okay, one person. Probably you know how its interface is, right? If you use WinDebugger, you will start to realize that your brain is going to melt from there, and you can see it by looking at the mirror, and then you cannot sleep at that night. Because it's a perfect tool. You can actually do anything with it. But it's like, I don't know, it's like this robotic surgeon things that you can do surgery with robots. It's like that. You can do, the surgery with the robot, but it's so hard for me to use it. And Memory Profiler does a great job of, pushing that interface from me and then giving me nice stuff, and only put stuff that I need to care about in my face with this summary page that you can see here. And then it also gives you what's happening inside your memory. So you can see here that for each object, how much memory I am actually allocating for my process. And then here, it also gives me a deep dive on what is inside my code base, and then what is the problem. So in this particular case, what the problem is that this thing is taking too much memory. So I will show you a demo with Memory Profiler as well. So I have another application here. If I can just find my cursor. Can't find it. Yep, here it is. So I have another application which downloads some file from somewhere, and it is this guy. So it actually has a really simple code base, and then if you look at this is the guy who actually downloads the file and saves it to disk. So it goes to a URL, downloads it, makes an HTTP request, and then opens up a stream. As you can see here, I am doing the nicest thing, which is getting the stream, right? It is the correct thing to do, because I don't want to actually take memory. I just want to get it inside the stream, which is probably going to be the network stream, and I just want to give it to the file stream so that it will not consume any memory. But it is somehow not the case. I'm not sure why. But I will see that. I will look at it in a moment. So here, if I open up memory profiler, this will profile that application for me. I can say new profiler, and I will select the .NET executable. There are so many options that you can choose. You can actually profile a live IIS application if you want to. You can actually profile an ASP.NET 5 application. You can even profile a SharePoint application if you are still running SharePoint. And then there are a bunch of things that you can customize here, but I will hit save. Okay, it was already running, so it stopped working for me. It stopped working, probably I don't have an internet connection. Luckily, I already have the results for you. Pretend that it ran. Okay, so what I did was very simple. I just ran it, and then I just hit this button here, which was take memory snapshot in a particular time that I know there is a problem. So I took a snapshot at the very beginning, and I took a snapshot when the memory was getting bigger and bigger. So it was consuming 40 megabytes of memory, nearly. But I wasn't expecting that. I was just expecting it to consume like 10 megabytes of memory because I was streaming, right? And it turns out to be the case that I was actually not doing it nicely. So here, when I look at it, I am seeing that I am allocating a byte array, which is nearly 28 megabytes in size. Okay, what might that be? So let's go inside here. Okay, it tells me that this is the thing actually inside my memory, and it is coming from this guy, which is systemnet HTTP content and limit memory stream. Okay, it's coming from a stream, but it is saying that it is a memory stream. So there is something going on here. I don't want a memory stream, I want a network stream, which you haven't consumed yet. But it is not the case in HTTP client, which is very tricky to get right. So this is the request that I'm doing, and I'm saying that read the stream, but actually what you should have done is this guy. So you should say that only read the response headers, not read the entire thing. So this is very common to do in a web application, to send some HTTP request and get back a response, right? So if you have large things to consume, and if you do it in a way that it will read all the response at the same time, you can get into memory situation. But in this time, it will just read the headers for me, and then it will give me the other stuff. And then after reading the headers, I'm getting back a stream here, which will actually be a network stream at this point. And I'm also opening up a file stream, and I'm just copying it to a file stream here, which is actually quite efficient because I'm not hitting a memory at all. I'm just buffering some stuff and putting it on a file stream, and then I'm just going back and buffering some stuff as well and then putting it there. So there is a little memory consumption there, but it is so efficient to do this. So which actually solved the problem for me. But I needed to understand what was happening. So memory profiler gave me that choice. You can get the same benefit with other tools like WinDebugger, which is a tool from Microsoft. But as I told you, it has a very hideous user interface. It's hard to use, but you can do so much clever things with it. Sometimes you may need to do that one. For example, it's one of the cases is whenever you have a problem in IIS, for example, or a running application, you may want to capture it in a way that it will only capture the memory snapshot whenever you have a problem. So for example, whenever your CPU hits like 50%, you want to take a snapshot. Whenever you throw memory exception, out of memory exception, you want to take the snapshot. So these type of cases can be done by a tool called ProcDump. How many of you guys know ProcDump? Cool, a few guys. So ProcDump is okay, one more, okay. You don't know about ProcDump. You are just telling me that, okay, cool. Cool, okay, 2 minutes. So ProcDump is a tool, command line tool that you can use to take dump files. And then you can analyze those dump files with WinDebugger. And then here is a simple command that you can run. Whenever it reaches a handle count of 10,000, it will take a dump. Which didn't sound quite right. But it takes a dump. Well, there's nothing I can do. Okay. So there's another thing for profiling server applications is that you also need to profile your server as well. So one of the ways is to event logs, and then the other one is the performance counters you have inside your server. So this is the performance counter viewer in Windows. So you can select some stuff like how many bytes of memory do I have, how many memory do I have inside the heap, inside Gen 0, Gen 1, Gen 2. So you can always profile this type of stuff. And then you can look at the event logs. And as I told you, you can take these from a command line tool, for example, from PowerShell, put it on a file on disk, and then make logstash, collect them, and then put it on Elasticsearch. And then you can then analyze it all together and then see that, okay, for example, whenever you have a problem at like 3 p.m. for some requests, you can look at the server logs for 3 p.m. and you can see that, okay, my CPU is taking too much time. You can look at the, for example, garbage collector, and you can see that garbage collector is doing some stuff at that time. So it's why it is taking time. You can understand this type of stuff by looking at this type of things. Another thing is load testing. Load testing is, I think, very important if you have a system which has a high concurrent users. It's like, you know, hosting a party at your house. Let's imagine that you have a house and then you are going to host a party for, you know, 100 people. But you don't know what's going to happen because you have never done this before, right? So you may want to throw a warm-up party. And then you may see that, okay, there is a cube in front of the bathroom. So you need to build another bathroom to host a 100 people house party or whatever. So for these type of cases, you want to know what's going to happen before you hit the production. So load testing gives you that. For example, this is a Visual Studio interface that does the load testing and it analyzes it for you. And there are some other tools out there which does it. For example, Apache benchmark tool. It's a command line tool, and you can say that, okay, hit this endpoint in this concurrency and then in this frequency, which is nice. There's always also another thing called network profiling. For some network problems, you can analyze them, what's being sent and received by Fiddler or Wireshark if you want to go deep. So this is what I was actually referring to you as, you know, very low-level problems. So network problems are one of them. So that's all for me. Thank you very much for listening. I highly recommend you to go and check this ebook. We also have a stand out there, and you can also sign up for the ebook there. And then there are some more books there if you want to. Some T-shirts and some mugs as well. There's definitely check this book out. It's awesome. It's free. There are also some resources here. I will try to put this slide on my blog so that you can actually get a hold of it. But if you want to take a photo, here it is. Thank you very much. If you have a question, I will be out there in front of the Red Gate booth for the whole day. So it's always nice to have discussions. Thank you very much for listening.